project, we recorded kinematic data from Kenzie, located over here, pushing me, Spencer, on my bike. So to start, we took a recording of it and uploaded it into the tracker software to record basically just displacement that we have here, and from displacement we took that, made it to velocity, and to start we looked at the time that Kenzie was applying a force to me on my bike. So basically we just did this and looked at when she started at time 0 to when she released me on my bike, which we found, if I can stop it at the right point, to be about 1.1 seconds. So yeah, for our calculations we use this point, so we'll go ahead and do that. So from here, the force was applied for 1.1 seconds. We analyzed our data, and we did a line of best fit here to show that my acceleration was about 1.4 meters per second squared. And then so now that we have our force, we need to, or the time that the force was applied, we just need to look at the distance that it was applied for, and the length, or yeah, just the distance it was applied for. So for that we can just look over here and see that it was started at 3.685 and subtracted that from 3.026. The tracker data started me at a negative displacement, so we're going to start with my final, which was positive, and that was 3.685 meters. And we're going to subtract that negative, which was a negative 3.026 meters, which gives me a total displacement of 0.659. And then we know that we need to find force and power, and we of course need to start with force. So we're going to use F equals ma here, and for m we're just going to combine the mass of my bike and the mass of myself and multiply that by the average acceleration, which we found from tracker, and that gives us a force of 116.19 newtons, and that's the force that Kenzie was pushing me with. So to find power, we know that power is work over time, so we're going to need to find work, and work is going to equal force times displacement, which we can see over here. So we can use the force that Kenzie pushed on me and my displacement, which we solve for over here, to find that the work she did was 76.57 joules. And now that we have that, we can plug that into our power equation, and the time that she was pushing me by looking at the tracker video we found was 1.1 second. So we divide those two and we get 69.61 watts. And that was all of our calculations for the physics project.